Our next lesson is called Inequalities with Set and Interval Notation Day 1. First, you're going to complete a mini activity. Follow the operations on the right-hand side in order to change the inequality. Be sure the inequality symbol still makes sense. When you're done completing the table, you're going to answer the question under results. What happens to the inequality when you multiply or divide by a negative number? So please pause the video and then resume when you are ready to go over the answers. Okay, so we are going to start by adding 2. So 2 plus 2 would be 4. 6 plus 2 would be 8. Do I still use the same inequality symbol? Yes, 4 is less than 8. Then I'll subtract 2. So I'll have 2 and 6 is less than is still appropriate. If I multiply by 2, I have 4 and 12. 4 is still less than 12. When I multiply by negative 2, I get negative 8 and negative 24. And for the first time here, multiplying by negative 2, negative 8 is not less than negative 24, it's greater than. So I'm going to switch the symbol to is greater than. Then I will divide by 2, which is negative 4, and negative 12. Negative 4 is greater than negative 12, so it's the same inequality as the line above. And now I'm going to divide by negative 2, which makes this a 2, and this a 6. And now here's the second place I had to change my inequality symbol because 2 is less than 6. So what happens to the inequality when you multiply or divide by a negative? The symbol flips or switches, however you want to think of it. And that only happens when we're multiplying or dividing by a negative number. Okay, so we're going to recall the properties of an inequality underneath. We have the addition property of inequality that says if you start out with A is greater than B, and then you add C to both sides for any real number C, you're still going to have the same inequality. We have the multiplication property of inequality. So again, if you start out with A is greater than B, and this time you multiply each side by any positive real number, okay, you're still going to have the same inequality, but underneath we're going to star because we have the special situation here where if A is greater than B, but then you multiply by K and it's negative, your symbol's going to flip. So you're going to notice here it was greater than and now it's less than. So as we solve these inequalities, we have to keep that in mind. If we multiply or divide by a negative anywhere in the solving process, we will have to flip the symbol. So for examples 1 through 3, express the solution as inequality in words and graphically on the number line. So that's 3 things they want us to do: inequality, words, graphically. So remember, solving an inequality is going to take the same steps as solving an equation. We just have to keep in mind the symbol flipping when applicable. So the first thing I see here is distributive property. We're going to distribute the 4 through the parentheses as well as the 2. So 4 times x is 4x. 4 times negative 3 is negative 12. 2 times x is 2x. And 2 times negative 2 is negative 4. Then we would look for like terms. On the left-hand side, nothing I can combine. On the right-hand side, nothing I can combine. Next is variables on both sides. We do have variables on both sides. We have 4x and 2x. I tend to be the person that gets rid of the smallest one to avoid negatives. So I'm going to remove the 2x by subtracting 2x. Whatever I do to one side, I'm going to do to the other. So 4x take away 2x is 2x minus 12 is greater than still because all we did was subtract negative 4. Now I will add 12 to start isolating my variable. So I get 2x, still the same symbol, all I did was add, and an 8. And then I'm dividing by 2, but that's a positive 2. So again, no need to switch my symbol. So I have x is greater than 4. So there's my inequality. Now I need to write it in words. That would be x is greater than 4. And then I need to graph it. So you know when you're graphing an inequality, you have to think about if that number is included or not. The 4 is not included because it's only greater than. So to show that, I'm going to make an open circle on 4. X is greater, so I'm going to shade where the numbers are greater or larger than 4. That would be to the right. We'll now go on to example 2. We have 0.5 times 6x minus 3 is greater than or equal to 3 times 1 plus x. So again, we're simplifying first. I see distributive property that needs to be used on both sides. So 0.5 is the same as half. So think of it like that. Half of 6x would be 3x. Half of negative 3 would be negative 1.5. Greater than or equal to 3 times 1 is 3. 3 times x would be 3x. So then I would look for like terms. There's none on the left to combine. There's none on the right to combine. So we go into variables on both sides, which I see we do have. So they're the same. It doesn't matter. I'll subtract 3x. And what's going to happen is our x's are going to be eliminated, and we have negative 1.5 is greater than or equal to 3. Is that a true statement? Is negative 1.5 greater than or equal to 3? It is not. So we're going to slash it. And that counts as my inequality. Now we're going to talk about what it is for words. So we're going to say negative 1.5 is not greater than, because we slashed it, right, is not greater than or equal to 3. Therefore, what we have here is no solution. So we're going to write, therefore, there is no solution. So that's my answer in words. And then again, if I don't have a solution, I have to leave myself with an empty or blank graph. There's nothing I can be graphing if there's no solution. Dashed equal sign. So we're going to start solving this by getting rid of the 8 and subtracting it from both sides. So we have m divided by 3. These are gone. Does not equal 1. Now, at this point, you could write 1 as a fraction and cross multiply, even though it's an inequality. That is still okay to do. Okay, so you could put this over 1, cross multiply, and you would get m does not equal 3. Your other option would be to have m divided by 3 equals 1 and just undo it by doing multiplication. So m equals 3, or does not equal 3. Okay, so either one is fine. So then we have to put that into words. We have m is equal to all real numbers, because it's pretty much everything. But then we're going to say except 3. So that's how you're going to word it if we have does not equal. So when we think about graphing this one, we have to think about the number 3 and whether it's included or not. We know it is not. It's all real numbers except 3. So we're going to put an open circle on 3. But then we have to show all real numbers. So we have to shade above it because all of those numbers count. And we also have to shade below it because all of those numbers count. So now we want to look lastly at another way to write these types of solutions, and it's called interval notation. So interval notation is a type of notation where you write subsets of the real number line. So on the chart on the right, this is a reference chart for you to use so that you understand how to convert all these different types of inequalities into interval notation. One thing you're going to notice when you look at that table is that instead of is less than, you're going to see parentheses. So get in the habit of recognizing that is less than or is greater than. I'll pick this one down here just to show you. Anything where the number is not included is going to use parentheses. When the number is included, so when you have or equal to, you're going to notice use of brackets instead. Okay, so that's something we kind of want to take a look at here and understand that those two things are equivalent. So we'll put less than or equal to, greater than or equal to. We're going to use brackets because that means it's included. Less than or greater than, we're going to use open parentheses because that means they are not included. So I want to do just a couple examples over here on the other side with you. We have the inequality, let's do x is greater than 4. If I was going to write that in interval notation, I know it's going to be parentheses because it's not included. And you need to think about this as 4 is your lower number or is 4 your highest number? Well, because x is greater than 4, that means 4 is the lowest it can be. So we're going to put 4 on the left-hand side, then a comma. And we're going to put a parenthesis around it because 4 is not included. Now, for the ones where it can continue going on forever, as long as it's greater than 4, we put the infinity symbol, and there's always a parenthesis around the infinity symbol. You're never going to be able to include it because it goes on forever and ever. Another one I want to specifically talk about is no solution, since that is not in the chart. We taught you how to do set notation with no solution, and we talked about a symbol that looks like this. This symbol is exclusively used when we use interval notation. And then what also is not addressed in the chart is something like what we did in our last example, where we have m does not equal 3. I want to show you how something like that might be written. So that means we have all the numbers leading up to 3, and then we have all the numbers after 3. So we're actually coming from negative infinity. We're coming from the lowest number, which we talked about would not be included. And we're going up to 3, and again, not including it. Then you're going to put a union symbol because we're going to connect it with the other side of where we shaded, which is starting at 3 and going towards infinity. That one you definitely would not see as much. As long as you're mostly comfortable with what you see in the chart, you should be good. And we are going to spend more time talking about interval notation. This is just a brief introduction. And that concludes our lesson on inequalities with set and interval notation, day 1.